In order to finish this series of video lectures related to real-time operating systems, I'd like now to talk about the real-time specificities. As I said already, real-time means that the system possesses explicit temporal constraints. Some tasks must be done before a given deadline. So, a real-time operating system is an operating system that offers services for real-time operation. And the validity of the process now does not only depend on the result, the data itself, which is what we add in regular operating systems, but on the time where the result is made available. The system is, as a result, deterministic, and that's what we want in many critical applications. So how is that done? Well, it is done through scheduling, and we're going to introduce priority levels, so it's not only going to be a standard round-robin scheduling, as well as use of preemption to handle critical events. So those critical events will not only be dealt with through priorities, but also with some modular priorities that we'll review very quickly. Round robin will still be used to manage tasks of similar priorities, so we want to make sure there is no starvation in the remaining tasks. So let's look at a couple of task models related to real-time operating system. Now I'm going to first look at the notion of cyclic tasks. So in the cyclic tasks, we are going to wait for some time after we're done with the task. So let's look at what we have here. So the arrows pointing upwards will be the task activations. On the x-axis, you have the operation over time, and what you'll see is that the processing of our task started, got interrupted for implementing some other task, resumed, and so on and so forth. When the task is fully done, meaning when all the execution time of your task was completed on the CPU time, you will wait for X ticks before activating the task again. The activation, by the way, does not mean that the task is running immediately. It simply means that the task has been moved from blocked to ready. There is this other notion of periodic tasks. So in a periodic task, now, the activation of the tasks are happening at a fixed interval of time. So in this particular case, we're not just waiting for some time after the task finished, but we're going to activate that at a very cyclic and periodical interval. So depending on which task model you're using, you'll be able to have different capabilities to implement your system. So one of the first real-time operating system scheduling is the priority task scheduling. So you will do some processing with higher priority guaranteed. And as I said, round robin is using to use arbitration for same level priority scheduling. So the danger in particular case is for lower priority processes that can still starve if a task of higher priority always executes. There's an example below where you have three tasks where task A has a louder priority than B and C, and those tasks do have a cyclic model, so you wait 5, 2, and 3, and depending on how long does B and A take, C might never get executed. What you can do is to implement a similar timing diagram as we had in the previous slide to understand how the tasks are going to be executed. So in order to avoid that, one could use this notion of periodic tasks with deadlines. So now a periodic task with deadline, every single task will be activated after a given period, but you also have this notion of deadline D, which is the violet arrows pointing downwards before, that needs to be respected. So the task needs to be executed before this deadline. In this particular case, we have another type of scheduling algorithm that is called the earliest deadline first, and now the scheduler will select the task whose deadline is closest, and that task will get the priority. I'm not going to run through the specific example of this slide, but I invite you to go through that, looking at the various times for the activation, the time the tasks take to execute, and when the deadlines are coming. As you can see right here, you're able to schedule and guarantee that these two tasks are running before the deadlines.